Hello, my name is Raza Noor, and I'm in 11th grade, and today I'm going to be talking about the amoeba Naegleria Fowleri. So Naegleria Fowleri is a brain-eating amoeba that can cause severe brain damage, and it usually results in death with a 97% mortality rate. It is mainly found in freshwater locations and places where water is generally unclean. The amoeba enters the body once water goes up the nose, and from there the amoeba makes its way through the olfactory cavities and into the brain. Once infected, people will begin to experience symptoms of PAM, or primary amoebic meningoencephalitis, and some common symptoms, according to the Cleveland Clinic, are headaches and fevers, along with coma, and eventually, if left untreated, after about 2 weeks, it can lead to death. It's important to study this amoeba since with climate change, the geographical range of the amoeba is increasing, especially potentially since the food source of this amoeba, algae, is also increasing with climate change. So for this research, I wanted to look at how this amoeba is diagnosed and how it is treated, and I wanted to gain a better understanding of the new treatment methods and methods of diagnosis that were being developed. I also wanted to gain a better understanding of how PAM progresses and also some variability in the infection. For example, some questions that have been raised are, why do some people survive infection, the 3% who do, while others do not? And also, why do some people get infected while others do not? So really overall, I wanted to gain a better understanding of how the amoeba is diagnosed, the treatment, and how infection progresses. So first off, I'd like to begin by discussing diagnosis. So there's three main methods for diagnosis. The first is a CT or MR scan. So a CT scan is basically an X-ray, while an MR scan uses radio waves and magnets to generate an image of the brain. And these can show inflammation and brain damage that's caused by PAM. For example, the image below shows a CT scan, and if you look at the image A, the arrow points to a ganglial infection that happened in a PAM victim. In addition, cerebrospinal fluid analysis can be done. So first, a lumbar puncture is done in order to gather a sample of the CSF, and then from there, there's two ways to analyze the CSF sample. So first, the CSF sample can be stained and then analyzed under a microscope to identify Naegleria Fowleri, or polymerase chain reaction (PCR) can be used to identify DNA of Naegleria Fowleri. Finally, a brain biopsy using stains can also be used using microscopic analysis to identify the amoeba. I'd also like to discuss the pathogenesis of the amoeba. So from my research, I found two main ways that Naegleria fowleri can infect a person. The first method involves the blood-brain barrier. And so the amoeba can basically break its way into the brain by inducing inflammation that harms the blood-brain barrier, and from there the amoeba enters the brain and infects a person. The second way, the amoeba bypasses the blood-brain barrier, and this is done by the amoeba heading through the cribriform plate in the nose. The cribriform plate is the bone that connects the skull to the nose, according to Gomez and Pickup 2020. So after discussing pathogenesis, I'd like to discuss a few treatment options. So currently, aggressive drug treatment is used to deal with PAM. Drugs such as maltodextrin and amphotericin B, among others, are currently used. However, this treatment can only raise the chance of survival and is not a cure for the disease. There is new research that is being conducted that suggests plants such as Inula viscosa, the plant seen on the image on the screen, can be used as a treatment. Leog et al. Found that this plant has shown to cause mitochondrial damage in Naegleria fowleri. In addition to the other treatment, enurase inhibitors are also being investigated. Enurase inhibitors inhibit enurase, an enzyme in glycolysis. According to Lin et al., Miranes et al. Found in a rodent model, they had two groups, and both groups had 12 rodents. And so one group was treated with the hex inhibitor, a type of enurase inhibitor. They found that in the two groups, the one treated with hex had 8 of 12 rodents surviving, while the one that was not treated had only 1 out of 12 rodents surviving. They note, however, that hex was not a full cure, it only increased the chance of survival, and there was still amoebic activity inside of the rodents. There are a few methods to help prevent contacting Naegleria fowleri and causing a PAM infection. The CDC mainly recommends ways to prevent contaminated water from entering the nose, and they recommend using nose clips to stop water from entering the nose, or they recommend not diving below the surface of a warm or fresh water body. In addition, they say that if you need to clean your nose, use bottled water or filtered water in order to clean your nose. The methodology for this study was that it was conducted fully online with no physical sources, and sources were gathered from Google, PubMed, and other databases and sources. The results of the study are that PCR analysis of the CSF is a very beneficial method for diagnosing, since it can get rapid results within a few hours. In addition, immunoviscosal treatment is also seems to be promising, since it has the ability to harm Naegleria fowleri. So in this study overall, I was looking at the amoeba Naegleria fowleri and how it infects people and what treatments and options are being researched. This study helps to shed light onto this current research, but also helps to show some of the limitations of these current solutions that are being looked at. To answer some questions that were asked at the beginning of the presentation, so in terms of variability in infection, people are still unsure about why some people get infected and others do not, when it may potentially be due to the immune response that some people have. In terms of variability and survival rate, people are still unsure about that as well, but it potentially might relate to the time of diagnosis and the immune response that people have to infection. There are some limitations to this study as well, such as time constraints, knowledge constraints, and also that the study does not go into full detail on some of the things such as pathogenesis and treatments, so some potentially important details might have been excluded. So I'd like to thank Professor Morgan for being kind and supportive and always helping me with writing the paper, and his feedback was really beneficial in helping writing the paper. I'd also like to thank Professor Kate for being very supportive and helping with the research, and she really helped to direct the research and really form the topic. And overall, I really had a great experience with this research program, and it helped me learn more about this topic that I find really interesting. Thank you for watching.
Excellent. You want to stop sharing so that Professor Barkey can ask you a question? Go ahead, Professor Barkey.
Yeah. So good presentation, Raza. I remember like you had like you had another presentation, but this is very different than what you had before. And so just one question. So why do you think like it's difficult to treat this particular disease or not disease, like particular infection as compared to other infections?
Well, really, this infection is really rare. There's only been like in the past, like from like 1960 or 1980 to like now, there's only been like 100 to 200 reported infections. There's really not much to work off of. And then also, it's a living organism, and it's eukaryotic. It has a nucleus and everything like our cells, so that adds an added level of difficulty to forming a treatment.
Okay, good answer. And probably also due to the blood-brain barrier, there are very few antibiotics which actually cross, and then or antiparasites, agents which can cross very effectively and like kill the parasites. Okay, good job.
Yeah, great job. I have Professor Virgil, but I have a question for you. Are you homeschooled?
Yes.
How does that even work? I mean, I always wanted to know. If you can quickly give us a quick rundown about how you like homeschooling.
Well, homeschooling, you get to stay home most of the time, so that's kind of an added benefit. But you have to like stay organized, and your parents really help with that. My parents really helped with that a lot. And most of the time, I'm using like an online platform, using an online school to learn most of the stuff.
Okay, so do you have teachers, or you have to self-learn, or what is it?
Yeah, so I have teachers when I do those classes. Yeah.
Okay, yeah, because I don't know, I stay at home working, and I just get stir crazy. I have to see people, and that is like the biggest flip side of working from home. But don't you miss the social interaction, getting on the bus, goofing off with your friends and doing something stupid?
Okay, I missed that a little bit, yeah. But I do get some opportunities to go outside and talk with others sometimes, yeah.
Wonderful, wonderful. Where do you live?
I live in Florida.
Okay, the weather is good, so you're not going to miss, yeah, going there. Yeah, yeah. Okay, so thanks, Raza. That was a very interesting research and also talking to somebody who's homeschooled. Okay, I have a question now. When you go to college, there's no homeschooling in college, right?
Yeah.
You will go in person. Okay. Okay, and was there a specific reason you picked homeschooling?
I mainly started because of COVID and everything, so.
Okay, got it. Okay, thank you for answering my questions. Professor Virgil, question for Raza on his research.
Thank you, Coach. Well done, Raza. I just have a question. Considering your contribution to this field of research, what do you think needs to be what do you think should be done more in this particular field?
Definitely, I feel like the diagnosis has really taken some great leaps recently, and PCR has shown really great ability in diagnosing the disease quickly. I feel like treatment needs a little bit more work since right now there still isn't any cure for the disease, and yeah, there's only drugs and therapies that can help increase the chance of survival. There needs a lot more work and treatment for.
Thank you.
Thank you.
Job, everyone. I just want to thank, uh, yeah. So, Professor Virgil, anything you want to say before we end? And Professor Varkey, we'll go one by one.
I just wanted to say hats off to everyone. This is another feather in your cap. Congratulations for presenting all your research papers. So I want you to continue and pursue your passion in research. Do not stop writing, okay? We're still going to publish your paper next year. So I want you to continue what you've started. So we're almost done in the finish line. And hopefully, you will be able to share to the world the article that you've written and you've really, worked so hard and put a lot of effort to write. So thank you.
Excellent. Thank you so much, Professor Virgil, for mentoring and guiding our students. Thank you so much for your expert guidance in writing, your patience.